Okay, folks, another AP Calculus video. Okay, I think this is coming out to you on Monday. Okay, might as well jump. That was that song right there. Can't help but sing those types of things. Really rekindling my love of 80s music during this quarantine. Actually, I didn't need to rekindle anything. I love 80s music, especially if it's electronic. So, let's do our second day of exponential growth and decay. Really, it's gonna, kind of transition into AP review at this point during this lesson. But we spoke about it yesterday. If you just take a look at the homework real quick, hopefully the problems weren't too terrible. Usually it's just, all about getting what a K value is equal to, and then using it some other instant of time. Hopefully it was easy to understand the answers here. I don't think you'll have to worry about many of these problems on the AP besides something like number 5. Very popular. Might not be on your AP, okay, but you're obviously a special case. So here, number 5, remember, quantity is said to have an exponential growth or decay if the rate at which the quantity is changing is directly proportional to the amount of the quantity that's present. Just means you can multiply the rate of change, the rate of change is going to be equal to the amount of the quantity times a constant, okay? You could multiply the constant by the rate of change as well. They never really do that. Then they just want you to set up differential equations that are actually not exponential growth and decay, like number 5, the rate of change of population at any time t. They tell you it varies directly, and that's the same thing as directly proportional, by the way. It's just another way to say it. They'll probably say directly proportional on the AP exam. That's all I've seen. As the square root of the population. Remember, the rate at which the population is changing with respect to time, that's dp over dt. And that apparently varies directly as the square root of the population. They tell you the population is p, so square root would be radical p. And remember, if they're going to be equal to one another, if they're directly proportional, you can multiply one by a constant to create the other, okay? And like I said, they always multiply the constant by the right-hand side, not the rate. That's what I've seen so far. People look over here, they're like, that answer's not here. It's right here in, where is it? D? P prime of t. Remember, same thing as dp over dt, okay? It's the rate at which p is changing at any given instant. And then k times, instead of saying p, they call it p of t. Nothing wrong with that, okay? So that's the type of problem I would focus on, okay? Hopefully you printed out the other ditto. Okay, and we'll actually start with this problem right here, which is going to begin with exponential growth and decay, and then it's going to kind of transition into AP review a little bit, okay? And it is a calculator problem. This is 1996. You're actually allowed to use the calculator on all of the free response problems. Will they allow you to use a calculator on your AP exam that's going to be shortened? I don't know. We'll find out hopefully more about that today. Which is Friday. I'm making this video on Thursday, so you'll be watching on Friday. I'm losing my mind. No, actually, this is the video that you're going to be watching on Monday. All right, so hopefully we'll already have some information. AP should email it to you anyway, but I'll break it down in the next video when we get our official AP review going. We'll speak about that a little bit. Will you be allowed to use the calculator? If I was going to predict, I'd probably say yes, because could they stop you from using it? But regardless, something we'll speak about. Check this out. This problem gets a little weird. The rate of consumption of cola in the United States is given by this function right here. And you can see this is an exponential growth or decay. Y sub t equal to y sub 0 e to the kt. But it actually doesn't represent the amount of cola that's consumed. It represents the rate at which the amount of cola is consumed, okay? So it is a little bit wonky there. Usually those exponential growth or decays represent an amount, not a rate, but they can represent a rate. So this is kind of like really a prime right there, where S is measured in billions of gallons per year, and T is measured in years from the beginning of 1980. That's important. That means 1980 is our T equal to 0. And part A is really just what we've been doing. They tell you the consumption rate doubles every 5 years. That's going to give you the ability to actually be able to solve for K. They also tell you the consumption rate at the beginning of 1980, T equals 0, is going to be 6 billion gallons per year. That's your initial amount. They want you to find C and K, the proportionality constant. So first off, that we have our formula right here, S of T equals C e to the kt. Remember, C is the initial value, the value at t equals 0, the value of S at t equals 0. S represents the rate of consumption of cola. So C is going to represent the rate of consumption of cola at t equals 0, which they tell you is 1980 is 6 billion gallons per year. But they also tell you S is measured in billions of gallons per year, which is why you just want to put a 6 right there, not 6 billion pretty antiquated these days. They don't really do that on the AP anymore, but just something to think about. So by the way, I have one value, right? I know C is equal to 6 right there. You know, C and K, do they want units? Maybe they do want units. So maybe you want to say 6 billions of gallons per year. 6 bilgal per year. And then if you want K, well, look, they tell you the consumption rate doubles every 5 years. So if it was 6 at T equals 0, 5 years later at T equals 5, it's going to be 12. And then T is 5. And now you can solve for K. Okay, 12 divided by 6 is going to give you 2, equal to e to the 5K. Okay, a distance that makes me, you know, lose breath just thinking about running. ln both sides. Take the ln of both sides. Was that too quick, right? The ln of e to the 5k, ln and e cancel out. You're just left with 5k. And ln of 2 over 5 is equal to k. Okay, so k equal to, you can even say 1/5 ln2 if you want to. And that's k. So as far as what unit it's measured in, it's not measured in a unit. It's just the proportionality constant. So there it is right there. Okay, so hopefully that first part isn't really too terrible. So now I actually know what S of t is equal to, and they're going to start asking about this function, represents the rate at which cola is consumed. We know it's 6 e to the 1/5 ln2 times t, which you really should write as 1/5 t ln2. It's the best way to write it out. Not that they needed that for part A, but it's going to be useful in part B. Part B, not the easiest thing to get because you got to start remembering things here. Hardest part of AP review. Find the average rate of consumption of cola over the 10-year time period beginning January 1st, 1983, which, by the way, is T equals 3, right? And then 10-year period would be up to T equals 13. Average rate of consumption of cola. You know, whenever you see the word average, you're either thinking it's the average rate of change formula or the average value formula. You know, newsflash, last I read, they're not going to put the average value formula on your AP. But we're going to review it like normal first, okay? Then kind of, you know, maybe the last few days we'll just kind of focus on those things that are only going to be on your AP. Because I want to make sure you guys know what you need to know for classes beyond this one, okay? It's not just all about the AP exam in here. Two ways to think about it. You might say the average rate of consumption of cola. You know, people might think it's average rate of change. But believe it or not, S represents the rate of consumption of cola, right? The rate of consumption, that's S of t. So you really just want to find the average of S of t over the 10-year time period. And you have S of t, okay? You have the function that represents the rate of cola consumption. So if you want to know the average of that function, that's the average value formula, okay? It's been a little while since we've seen it. All right, who knows last time you looked at it. But remember, if they want the average of a function they give you, that means you're going to use this formula right here. They want the average rate of consumption of cola. And S of t represents the rate of consumption of cola. Rate of consumption of cola. Cola, 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 cola. So now if I plug in here, I know that's really 1 over, what, 13 minus 3? Integral from 3 to 13 of whatever the heck you want the average of, and we want the average of the rate of consumption of cola. Not the easiest thing to understand. I told you, average value problems can range from being ridiculously easy to not so easy to understand. This one's tough, okay? Maybe like, you know, high, moderate type of difficulty right there. And AP review is kind of beginning right now, so it's okay for these things to not be so sure in your mind at first. Definitely a calculator situation to get what this answer is over here. We'll do a couple different things. I'll put my K in. So what was that? 1/5 ln2. ln2. Okay, I'll actually take that and store it in for K. And now when I go to y equals, I'll put this thing in y equals here. I'll put in S, so 6. And then you could say e to the, and now you could just say kt, okay, instead of having to write out that whole nasty thing. Obviously, we're not using t in the calculator. We're using x, okay? Split of t. But now I can set this up, little alpha y equals, fasciques, okay, 1 over, you could say 1 over 10, but saying 1 over 13 minus 3 just looks so cool. I don't know, I'm thinking a little math niner. Nothing could be better. Okay, and let's do the integral from 3 up to 13 of alpha twaithy to alpha twaithy y1 with respect to x. Okay, they don't say anything about actually rounding or anything like that. So my answer right here, approximately 19.680. And now I got to worry about units, okay? Indicate units of measure. Remember, you're taking the average value of this function. This function represents rate of cola consumption in billions of gallons per year. So the answer we get back is also going to represent billions of gallons per year. So gal per year. That's our answer right there. That might bother some people, and if it does, you might be like, wait, if you integrate the rate at which cola is consumed, we're going to get there eventually in part D. Then we'll speak about that again. Part B might have really